Thank you, Anthony. And thank you, Ajay, and thank you, Transform Events, for making this possible. Good day, everyone, and welcome to everyone around the world. Just share my screen, which I hope everyone is able to see now. So yes, welcome everyone, and it gives me great pleasure to present the real difference that our solutions, our AI solutions in particular, is making the changes in our customers. And today's presentation is all about presenting to you the real results of AI. As you know, in March we presented what AI is capable of delivering and what AI is able to deliver. And now, as we are continuing on the journey of implementing AI solutions at our customers, and this presentation is focusing around what real results we have delivered and will continue to deliver. It's a very exciting technology. I'm learning lots and lots every day about the possibilities of AI, and it gives me great pleasure to share this, share the real results with you today. So I always bring this slide up. Because, you know, we need to adapt to the changing environments around the world. If we don't adapt to the change that's going on, COVID-19, climate change, congestion around the world, ships now missing port calls and dumping containers in other terminals, it's a real ever-changing, chaotic world that we need to deal with, and we need to adapt. If we don't, we lose business, lose money, and in radical situations, we may not even exist. And Darwin saw it many years ago, and it's a real eye-opener still today. Artificial intelligence is about the capacity of a computational system to transcend manually created soft and hard-coded logic. It's about letting the computer system make the decisions autonomously for us. And Dr. Rafiq will actually go into that in terms of autonomous decision making through the solutions that he offers. But the solutions we have do autonomous computation through software that has an impact into the daily operations of a container terminal. So how do we do this? Very two slide primer. Basically, we get any data that we can that makes an impact into daily operations. So weather, equipment, truck data, the vessel battery information, load plans, discharge plans, all that information we ingest and we assimilate. We then do a process of digitization, cleansing on that data. We create an operational digital twin, which is in real time. And then with that digital twin, we then start to predict and then to make decisions real time to make a difference in the container terminals operations. The kind of problems that we are addressing, and really quickly, we're trying to predict when vessels are going to arrive. With all the external factors going on, we're trying to ensure that the data from the previous ports is also of high quality from the liners. If it's not, then we will cleanse it. We will make it as clean and efficient as possible. Then we're trying to predict, can we better use our berth based on the vessel calls that we have? Then we're trying to ensure that the equipment stays operationally active and available in order for us to move the boxes efficiently around the container terminals. Then we're trying to predict, with all the factors going on around the world, what is the most efficient decking position using our AI in the container yard in order to make sure we take the optimum route, we reduce our carbon footprint in doing so, we make sure that all future moves for those containers are as minimum required as possible. And with all the disruptions going on the land side in terms of the trucks that come in a non-predictable manner, we're trying to make sure that the truck turnaround time is as efficient as possible. So there's a lot of predictions that's required and a lot of decisions that needs to be made. And all these decisions traditionally needs to be interconnected in the container terminal. And that's what we're trying to do. We're trying to connect all these decisions that is typically quite impossible for us humans to do at the speed at which it's required. So a practical example, we have a very large yard in Asia, which is one of our launching customers, and we work with them as a team to ensure the solution is delivered according to exactly what their requirements are. They currently have high utilization, uneven RTG loads. So for example, if you keep all your RTGs busy at the same rate, you will get a higher throughput. We reduce our rehandle counts, and we currently there's a high rehandle count, and we try and increase productivity. So this was the challenge that was thrown at us. So after a few weeks of operations, what we find when we compare the data, so one of their berth is our AI berth, and the other berth is the non-AI berth, doing expert decking in the traditional way. And you can see the bell curve has shifted in a positive way by 15% after a few weeks. And it's shifted to the extent that all RTGs are doing a higher productive work, but they're all doing their work consistently. And that's also had a very nice side effect in reducing the time taken for the prime movers to come to the RTGs from the vessel, from the waterside. And now we are implementing further optimization within the AI after we've seen how AI is working, and then rolling it out to the entire facility, because the confidence within the operations team has really grown, and we are working day to day with the operations team to ensure that they understand what AI is doing and how AI can deliver results, and allow them to focus on the decisions that really matter. And that's a real shift that we find at this facility, and it's a real pleasure to work with them. What we also find prior to the implementation of AI and now post-implementation, we find that the total moves required, the ratio with the prime movers has increased. So we've decreased the number of prime movers required. We've increased the active time of the prime movers for doing productive work, and we've increased the productive moves and reduced the number of prime movers required for those moves. In the RTGs, you find we've increased the number of moves done with less RTGs. Also, the distance travel has dramatically reduced, and the increased moves done by the RTGs has been increased as well. And so the total productive moves has gone up with less equipment, which is like sweet music, to any terminal operator. In terms of the unproductive moves, we find that we have reduced the rehandles. We've still got a way to go, and as I said, this is a journey of optimization with the terminal fully on board, working with all the operational staff. Total unproductive moves has gone down, and we're doing more work basically with less. Our second customer is a semi-automated facility in America, and they had some really strict requirements and phased-in requirements, which we're working with. And their requirements was to make sure that we do all housekeeping at night, because they're able to do so, because when the trucks come in the morning, they want to really reduce the truck turnaround time, and they need no manual intervention in doing so. And that was the initial actual measurement that they want. So increase the deliveries per hour, reduce the distance traveled, and reduce the rehandles as well. That was phase one. And basically in this journey that we've been doing with them, the XPS will continue to do the 45s, reefers, hazardous and waterside activity. But now, because of the results that they have seen in the current phase, they are now extending the phase to do a lot more with us. The waterside is now also going to be as part of our subsequent phases, which we're working on. So basically, again, we're taking truck appointments, current state of the yard, creating a digital twin. We load everything in the cloud, and we have our unique fast cloud processing facility that is milliseconds to get the data from the terminal. And we've proven that working at our Asian facility. And basically, this is the kind of streamlined architecture that requires no investment in the facilities infrastructure. We do all the heavy lifting there. So these are the results from the simulation that we've seen. We've seen humongous improvements. And as I said, this is in simulation. Real field trials with the American customer begins in July. Actually, very, very, very soon. July is not that far away. And the results actually speak for themselves. And we, again, have a really happy customer there. Our third and final case that we've also built a equipment site, which is a product that predicts when equipment are going to fail. And this is what Aldo was alluding to. And basically, we are predicting the failures of 59 AGVs. And these models have been running for a little while now. And currently, we are at 79% confidence level in predicting the AGVs failing. And we've identified 10 high-risk AGVs that would have actually stopped operations in their tracks if we had continued. So basically, we're taking and we've increased all the sensor activities that we have on the AGVs and recording all the sensors. And we've also found that the design of the AGV needed to improve in order to keep the AGVs operational. So one of the typical things is there's two antennas front and back of the AGVs that reports where they are. And in many of the AGVs, the vendor did not put the antennas in exactly the same position. Every AGV antenna had a different position and they were not aligned. And this also caused a problem in the AGVs losing their routes. We highlighted that during our simulation models, and actually we've really had a big impact in making sure those AGVs stay operational. We've reduced the maintenance cost. Apologies. We've reduced the maintenance cost and also increased the equipment availability, because our predictive models do work, and the customer is actually trialing these on a day-to-day basis. So with that, I would like to finish by saying, our job is for the future is to make sure we can, it's not to foresee it, but to enable the future to happen so we can deal with the solutions and problems much sooner. With that, Anthony, I hand it all back to you. Thank you very much.